Assalamu alaikum students. I hope you people are doing good at your homes. We are continuing the topic actually, the law of definite proportions. I told you people regarding this law of definite proportion that it was actually the J.L. Proust, the French chemist, who put forward this law. And according to this law, in a pure chemical substance, the elements are always present in definite proportions by mass. And according to this law, and this law is also called as law of definite proportions, because this means that whatever may be the source from which a compound is obtained, it's always made up of the same elements in the same proportion by mass. So we discussed this law in the previous, I think in 2 or 3 lectures. We discussed this thing wholly or solely. I made you people understand what actually this law of definite proportion is. So regarding this law of definite proportion, I would like to add one more example here, that I told you people that there should be the, I can say, definite proportion whenever the elements combine with each other to form the compound. That's why the statement tells us that in a pure chemical substance, the elements are always present in definite proportions by mass, or a pure chemical compound always contains same elements combined together in same proportions by mass or weight. We discussed this thing. And I would like to put forward one more example here, that's regarding the law of definite proportions. This means that whenever there is a formation of a copper carbonate, this is copper carbonate, CaRBonate, that is copper carbonate. Whenever there is a formation of a I can say copper carbonate, that means that this is the formula of the copper carbonate. Copper, symbol of copper is Cu, and this is carbonate, CO3. This is the formula of a copper carbonate. And as far as this copper carbonate is concerned, here also you will see the definite proportion. In copper carbonate, there should be the 51. This is 51.36 copper. Whenever there is a formation of a copper carbonate, that means this copper carbonate is actually a compound. And I told you people, whenever there is a formation of a compound, elements, 2 or more than 2 elements join with each other to form the compound. And same is the case with this copper carbonate. Whenever there is a formation of a copper carbonate, 51.36 grams of copper reacts with 9.72%, means 9.72% of carbon reacts with this copper, plus 38.85% of oxygen reacts with each other to form this copper carbonate. You will see the definite proportion here. So the definite proportion, law of definite proportion, tells us that in a pure chemical substance, the elements are always present in definite proportions by mass. Means that as far as this copper carbonate is concerned, if this ratio fluctuates, it is that impossible for we people to make this copper carbonate. So to make the copper carbonate, the ratio should be 51.36% of copper should react with 9.72% of carbon should react with plus 38.85% of oxygen. That means whenever the elements come, copper is one element, carbon is another element, oxygen is another element. Because regarding the elements, I told you people that these elements are made up of single type of atoms, and when these elements combine with each other, there's always formation of a compound. Well, same is the case with this law of definite proportion. Whenever I talk about this law of definite proportion, there should be the definite proportion between the elements. Means whenever the elements combine, they are always, I can say, whenever the elements combine, they always contain same elements combined together in the same proportion by weight. That's why I told you people, in formation of a copper carbonate, there should be the ratio of copper should 51% of copper should react with 9.72% of carbon plus 38.85% of oxygen. Then copper carbonate will form. This was actually the another example of the law of definite proportion. Now we are going to discuss one of the numericals regarding the law of conservation of mass. We discussed 2 important laws: one law of conservation of mass and one is law of definite proportion. So today we are going to discuss one of the numericals regarding this law of conservation of mass, in which we are going to discuss one of the numericals regarding the law of conservation of mass. Firstly, let me recapitulate what actually I told you people in the law of conservation of mass. I told you people that this law deals with the relation between the mass of the reactants and the products, And this law was given by the French chemist Antoine Lavoisier in 1774. I'm recapitulating the law of conservation of mass. So, regarding the law of conservation of mass, this law is also called as law of indestructibility of matter, or in other words, law of conservation of mass means that mass can neither be created nor destroyed, but it can simply change from one form to another form, or during a chemical change the total mass of the reactants is equal to the total mass of the product. So the data is given. We have to actually discuss, is the mass of the products equal to the mass of the reactants? Is the mass of the reactants equal to the mass of the products? Then this equation follows the law, this reaction follows the law of conservation of mass. Then means that this numerical is in accordance with law of conservation of mass. So we will discuss this numerical. Firstly, in a reaction, 5.8 grams of, look, this is very important concept here, 5.8 grams of sodium carbonate. Firstly, we will write down chemical formulas of these reactants and products. Sodium carbonate, the formula of sodium carbonate is Na2CO3. Mark my words, students. We will first jot down the chemical formulas of these reactants and products. Sodium carbonate, this formula of the sodium carbonate is Na2CO3. Sodium carbonate. Second is with 8 grams of ethanoic acid. The formula of ethanoic acid is CH3, jot down, students, CH3COOH. This is a formula of ethanoic acid, and this ethanoic acid is also called as acetic acid. Acetic acid. You might have heard the vinegar name. Vinegar. In vinegar, you will see the acetic acid present there. So, 8 grams of ethanoic acid, the general formula or the molecular formula of ethanoic acid is CH3COOH, and this ethanoic acid is also called as acetic acid, and this is also called as carboxylic acid. Carboxylic acid. So, this is why the two names. Now, jot down. The products were 3.7 grams of carbon dioxide. This is a formula of carbon dioxide, CO2. Formula of carbon dioxide. 0.9 grams of water. Molecular formula of water is H2O. Mark my words, we are writing down the molecular formula of these reactants and products. And then we will solve this numerical. The products were 3.7 grams of carbon dioxide and 0.9 grams of water and 9.2 grams of sodium ethanoate. The formula of sodium ethanoate is CH3COONA. The formula of sodium ethanoate is CH3COONA. This is also called as sodium acetate. Sodium acetate. So this CH3CONA is also called as sodium acetate because, look, this CH3COO negative, this is called as acetate ion. Mark my words, it's a very important question. This is a very important topic here. CH3CO negative, this is acetate ion because it contains the negative charge. So this is acetate ion, and with this acetate ion there is a presence of a sodium. That's why I told you this is also called as sodium acetate. So CH3COONA is also called as sodium acetate. Sodium acetate. So these were some molecular formulas of reactants and products. These were some of the molecular formulas of reactants and products. Why I wrote the molecular formulas of these reactants and products, it will I can say become more easier for you people in solving this numerical problem. So in a reaction, before discussing this numerical, you people should keep in your minds, rather you people should remember that during a chemical change, the total mass of the reactant should equal to the total mass of the product. Then law of conservation of mass will get followed. So in a reaction, 5.8 grams of, firstly we will jot down reactants. I told you people in the previous lectures what actually these reactants are. These reactants are the starting material. In a reaction, 5.8 grams of, this is sodium carbonate, that's Na2CO3, 5.8 grams, reacts with 8 grams of ethanoic acid. I told you people the formula of ethanoic acid is CH3COOH. It says 8 grams. So these are reactants. When these reactants combine with each other, they form the product. So we have two reactants. One is sodium carbonate, another is ethanoic acid. First is sodium carbonate, second is ethanoic acid. This ethanoic acid, I told you people, this is also called as acetic acid. So 5.8 grams of sodium carbonate reacts with 8 grams of ethanoic acid, acetic acid. These were the reactants. Now products. The products were, when these two react, means when sodium carbonate plus acetic acid reacts, there is formation of carbon dioxide plus water plus sodium ethanoate. The formula of the sodium ethanoate is CH3COONA. So we have 3.7 grams of carbon dioxide. We have 0.9 grams of water. We have 9.2 grams of sodium ethanoate. So this was the data. So as far as reactants are concerned, we have two reactants. One is sodium carbonate, and that is 5.8 grams, and we have acetic acid, that is 8 grams. And when these reactants react with each other, there is a formation of a carbon dioxide 3.7 grams, and water 0.9 grams, and sodium ethanoate 9.2 grams. So this was the data. Jot it down. So according to the law of conservation of mass of reactants should equal to mass of products. Look, mass of reactant should equal to the mass of the product. So mass of the reactants is, first reactant sodium carbonate, that's 5.8 plus 8 grams of ethanoic acid, that is 8, that equal to 13.8 grams. It's a mass of the reactants. It's a mass of sodium carbonate and mass of ethanoic acid. Now mass of the products. Carbon dioxide 3.7 grams plus carbon dioxide 3.7 grams, water 0.9 grams plus sodium ethanoate 9.2 grams. This is the mass of the reactants 13.8. Mass of the products is 3.7, that is 3.7 plus 0.9 added 9.2, that is 13.8. This also comes out to be 13.8. This means that mass of the reactants is equal to the mass of the products. So this numerical follows the law of conservation of mass. So this numerical follows the law of conservation of mass. This numerical is in accordance with the law of conservation of mass. The mass of the reactants was 13.8 and the mass of the reactants was 13.8 and the mass of the products were coming out to be 13.8. That means mass of the products, mass of reactants is now equal to the mass of the products. Mass of reactants is equal to the mass of products. So this equation follows the law of conservation of mass. Hope you people have enjoyed this. Till then, we will in next lecture we are going to discuss some more numericals regarding the law of conservation of mass and the law of definite proportions. Till then, stay safe, stay at your homes. Allah bless you all and keep practicing.